Everyone, and welcome to the last lesson of topic 2. Today we are going to talk about writing the equations of our parallel and perpendicular lines. So just a reminder from what we've been talking about for the past few lessons, when our lines are parallel, their slopes are equal, and when our lines are perpendicular, they're what we call opposite reciprocals, where our product of our two slopes are equal to -1, or in other words, we have slopes whose slopes one is positive, one is negative, and then they are flipped fractions of each other. So we will need that information for later. Now, when we are writing the equations of lines given a point, we are oftentimes given a slope, but we don't know what the y-intercept is. So if we use that point and plug it back in, we're able to solve for what our y-intercept would be and then plug it back into the equation. So when we want a parallel line to a given line, we are going to have the same slope, right? If they're parallel, the slope of the original is going to end up being the slope of our parallel line. So that's 2. And then if we want to write the equation of a line through a new point, in this case, 1, -1, we can use that information to help us actually solve for our b value. So our slope of our parallel line is the same as the original 2, and then our x comma y to plug in our 1 and -1. So we can do that, right? Our y value is -1, our slope value is 2, and then we have an x value of 1. And if we simplify to solve for b, -1 is going to equal 2 times 1, which is 2, plus b. Subtract the 2 over. We end up getting our b value to equal -3. Now our slope again is the same as the original. It was 2. Our b value now we just found to be -3. So the final equation of our line, y equals mx plus -3, aka -3. So there's the equation of our new parallel line. All right, the next example wants us again to write a line parallel to the given line. This time we are through the point x comma y of 2 comma 4. Again, if our slope was 3 over 2, the parallel slope is the exact same. It would also be 3 over 2. So again, we want to plug in y equals mx plus b. We know 3/2 is the slope. We don't know the b value. So we can plug in x comma y from the given and simplify. 4 is going to equal 3/2 times 2. Reminder in your calculator, just do 3 divided by 2. 3/2 times 2 is 3. So we do 3 plus b. Subtract the 3 over to get b by itself. This time our y-intercept of our new line is going to be 1. So our line is going to be y equals 3/2 x plus 1. Now this particular problem also wanted us to graph both lines. Notice this part here. So if we graph the original, we have a y-intercept of -3, and then we're rising 3, running 2 each time. Rising 3, running 2, rising 3, running 2, and then we'll go down 3 to the left 2. So we see here's our original line from up above, and then we can also graph our new line. Again, we start at 1, our y-intercept up 3 over 2, up 3 over 2, up 3 over 2. Notice we're going through the point 2 comma 4, so we see that that worked out. Down 3 over 2, down 3 over 2, down 3 over 2. So we see on this, these two parallel lines that are going through here, and then we can see they're having that same slope, same rise, same run. Now down below, they also sometimes are going to give this to us with graphically. So we are rising 3, running 2, rising 2, running 3. So our original slope is 2/3. And again, our slope of a parallel line would also be 2/3. So again, this is what we're going to use when we plug in. Y equals mx plus b. This time, our x and our y values to plug in. X is -6, y is 8. So if we start simplifying, 8 equals 2/3 times -6. So 2/3 times -6 is -4. So -4 plus b. And then add the 4 to both sides to get a total of 12 for our b value. So our line this time, which we don't have to graph, y equals mx plus b. All right, your turn to try. You're going to first look for the slope of this line and use its parallel slope. And then you are going to write the equation of that line going through our new point, 7, -3. You can first write down the slope, then write down your equation. All right, now, what if our lines are perpendicular, right? That's the question of the day. Well, our original slope in this case of this line was -3. So our perpendicular slope, aka the slope we're going to be using for our new line, is +1/3. So again, that's what we're going to be plugging in, is +1/3. And our new line is going to go through the point 3, 2. So if we start plugging this information in, we have our y value, our m value, and our x value to plug in. And we can start solving for b. So we have 2 equals 1/3 times 3, which is just 1. And then if we subtract 1 over, our b value this time ends up equaling, not 3, we're subtracting, ends up equaling 1. So again, our slope we're using for this perpendicular line is 1/3. Our b value is 1. And y equals mx plus b for this perpendicular line. Last example we are doing together is coming up with the equation of a perpendicular line from the graph. So here's our original line. We are going down, 5. 1, 2, 3, 4, 5. Over to the right, 1, 2, 3, 4 boxes. So our original slope, down 5/4. Now again, we need the slope of a perpendicular line, so it's now going to be +4/5. So this, again, is the slope that we are going to want to plug in to y equals mx plus b. To get b, we're going to plug in our x and our y values. Y is 3, x is -5. So 3 is going to equal 4 this times -5, which is just -4. So -4 plus b, add the 4, b this time is 7. So again, for a perpendicular line, we're using the perpendicular slope. Y equals 4/5 x plus 7. All right, try this last one on your own. What is your perpendicular slope? And then you are writing the equation for y equals mx plus b. Thanks everyone for watching, and we'll work more with these in class.